Hello, in this video we're going to have a look at working out what term number a particular value would be in a sequence. And in this video we're going to look at arithmetic progressions. I'm going to start off with a fairly straightforward question, and then I'm going to do a slightly harder one, so you can sort of just stop the video after the more straightforward one if that's what you'd like to do. So we have a sequence here that is 67, 63, 59, and we're asked what term in the sequence will be 3. Now I'm going to zoom out now and you'll see the slightly harder problem down below, but just focus on slide 2, which is where I'll write the solution. Okay, so we almost always start with the sequence formula for the general term, which is AN. I'll just put it in brackets over here. AN is equal to the first term plus n minus 1 times common difference. That's for an AP. And we just put in the values that we know. So what we're looking for is the term in which the sequence will be 3. So that's what AN is, right? That's the term itself is AN. So instead of AN, I'll put 3. And then we know the formula says I then write down the first term, which if we look at the sequence, we can see is 67. So we write 67 down. And then we write plus n minus 1. We don't know what n is, so we're going to have to leave it as just n minus 1. And then we write down the common difference. Now, if you look at the original sequence there, or the one that we're given there, we can see it goes from 67 down to 63, down to 59, and ... means, and so on. So there's a difference of 4 here, and then a difference of 4 here. So that's the common difference is 4. But because the sequence is going down, what we're adding is negative 4, right? So we always consider it from an addition perspective. We're adding negative 4. And so I will notate that. You can go times by negative 4 if you like, or you can write it in brackets, because then that will imply there's a multiplication between those two parts, which is what I usually do. I usually use brackets rather than multiplication symbols. You can't just write minus 4 without something in between, because otherwise it'll look like you're taking away 4 from n minus 1. So that's the hard bit, putting all that together. The rest of it is actually just doing your operations to work out what n is. So the first thing I'm going to do is I'm going to take away 67 from both sides. You don't have to do it in red like I'm doing it. It's just a way of me articulating my thinking. And that gets rid of the 67 from the right, and 3 minus 67 is negative 64 on the left there. So I've got negative 64 equals n minus 1 multiplied by negative 4. Then I'm going to divide both sides by negative 4. And the negative divided by the negative will make it positive, and 64 divided by 4. You could use your calculator if you weren't too sure about this, or use short-term division off to the side, but it is equal to 16. So 16 is equal to n minus 1. And then I'm going to add 1 to both sides to get n is equal to 17. I'll pop that in there just so you can see it. If you want to, you can put a conclusion in, i.e. the 17th term is 3. Okay, so just to summarize what we did there, we used the general form, the formula, and substituted in the values that we were given. In this instance, 3 is what we were given here. 67 is the first term, minus 4 we figured out. We then solved for n. This is a straightforward linear solution, but if you're rusty with solving for a value in an equation, I can see why this might be a bit more tricky for you. But nevertheless, we can see the n is sort of built into the brackets here, so we can't get to it yet. So our general rule of thumb is we remove the terms that don't have our unknown in it, so that's why I removed 67 first. We then divide out bits that allow us to get inside the brackets, which is why I divided by negative 4. That left us with n minus 1. This is the unknown, so I removed the minus 1 to get 17. Okay, you can see the slightly harder one down the bottom there, so let's have a crack at that. When will the sequence turn negative? Now, you might be tempted to put in negative 1 here, but I would not do that, because number one, we don't know where the negative 1 is a term in the sequence, and number two, although I can see it's impossible in this particular example. Oh, by the way, you can stop the video now if you don't want to go any further. So stop the video, go do some problems, and you're all good to go. So this is just a bit of extra work. What was I saying? So I can see that it's the term that it's not going to be a decimal sequence, but technically negative 0.1 is a negative value as well. So putting in a specific negative number is not that useful, I don't think. Instead, you should use this approach. We're going to start with the same thing, which is that general form, an equals a1 plus n minus 1 times d. But the value we're going to put instead is not -1, but 0. And what we're going to do is say, if I can work out the value of n for which the sequence would be 0, then I know that the next term is going to have to be negative. So we call this exploring the boundaries. The boundary value is 0. That's the boundary between positive and negative. So by putting in the boundary, I can say anything below the boundary will be negative. Okay, so we've got 0, and the rest of it's kind of the same, is equal to 67 plus n minus 1 multiplied by -4. Subtract 67 from both sides. I won't put the red in this time. I'll get -67 is equal to n minus 1 multiplied by -4. And here's the rub here. If I divide both sides by -4, and I'd use my calculator for this, I'll get a positive value again, but I'll get positive 16.75 is equal to n minus 1. Then add 1 to both sides, and I'll get n equals 17.75. Okay, so that tells me that 17.75 is when the sequence would be 0. But of course, n has to be a whole number. It's a counting number. It's a position of a term. There is no 17.75th term. That doesn't exist. It's either the 17th term or the 18th term. So you could conclude that by the 17th term, it'll still be positive, because if it's 17.75 is the 0 point, then the 17th term must be positive. And therefore, you would have to say, i.e., by the 18th term. I'll say a couple of little conclusion comments, and then I'll stop this video. Number one, even if this said 17.1, you wouldn't just round down to 17. It just so happens that I've rounded up to 18. If n equals 17.1, we could therefore say that at the 17th term, it's not going to be positive. So it's not going to be negative. So even if n equals 17.1, we'd still have to round up to the 18th term to say this would be the first term where it would be negative. The other thing I should just point out as well is that we can sort of confirm this by looking at the example above here where it says we worked out that n equals 17. And if I did have this already, then I could definitely just subtract 4 from this and see that the next term would be -1. And therefore, that would be the first term that was negative. And therefore, I could say by the 18th term, if I had this. But of course, I don't. So, well, I guess I do, but in a problem that you might be given, you probably don't have this bit here. So when we solve this problem, it's not knowing that there is a term that is really close to 0 already. Okay, so you would then do the process that I showed you, putting 0 in here, putting in the other information, and then solving for 0 to get a decimal number, which is definitely not part of the sequence. 0 is not part of the sequence, which is why we've got a decimal number. And then you almost always need to round up to the next number to say, well, it hasn't reached it by 17, so it will reach it by 18.